Good day, everyone. Our group is pleased to present on the topic of wafer transfer and lifting task manual, which we prepared as part of Occupational Health and Hygiene course KMO6043 at UNIMAS. So the focus of this project is to analyze economic risk in wafer transfer and lifting tasks and provide solution to minimize work-related musculoskeletal disorder WMSDS. So this manual serves as a practical guide to ensure worker safety and comfort in performing these tasks. Before diving into deep details, let me introduce first our group members. As you can see here, our team consists of 4 members per group. So the first one is Ryan Giggs Anak Paul Natu. Second, Nur Shamsina binti Ali Rahman. Thirdly, myself, Daya Nurisni binti Awang Zainal Abidin. And lastly is O'Brien Duncan Ricky Insol. So each of these members has contributed uniquely to this project, from data collection and analysis to designing agronomic solution. This collaboration reflect our commitment to address safety issues in the workplace, ensuring our findings and recommendations are practical and effective. This project focus on economic risks faced by workers at Longi, Malaysia, Sdn Bhd, particularly in tasks involving the transfer and lifting of wafers. Our assessment adheres to the guidelines on economic risk assessment at workplace established in 2017 and utilizes the RULA method. The primary goal is to identify economic risks, assess the severity of these risks, and propose solutions to enhance worker safety and reduce the likelihood of WMSDS. Okay, so Longi Malaysia, part of Longi Green Energy Technology, is a global leader in solar energy solution. The company promotes clean energy manufacturing and has established a significant presence in Kuching, Malaysia by leveraging local hydropower to power its operation. Here in this slide, you can see Longi's Kuching facility, which plays a critical role in its global solar energy production. Longi Kuching specializes in manufacturing solar ingots, wafer, and other components essential to solar panel technology. The facility employs thousands of workers, with its current workforce expected to grow to 6,000 by the end of 2024. Longi was founded in 2000 with the vision of becoming global leader in solar energy technology. The company's commitment to sustainability is evident in its innovative approach, such as the Solar for Solar business model, which focuses on using solar energy to power its manufacturing processes. Longi began operation in Malaysia in 2015 and has since expanded to Bintulu and Serenda alongside its Kuching facility by leveraging local hydropower and implementing clean energy alongside solution. Longi not only reduces its environmental footprint but also positions itself as a pioneer in sustainable manufacturing. The company's growth highlights the importance of ensuring workplace safety, especially as it scales up operation. The objective of this ergonomic risk assessment are comprehensive and targeted. First, we aim to identify and evaluate ergonomic risk in the workplace using the RULA method. This method allows us to assess work posture, forces applied, and frequency of movement during wafer transfer and lifting tasks. Secondly, we assess the severity of these risks by analyzing how they affect posture, force, exertion, and repeating motion. This ensures a detailed understanding of the impact on workers. Thirdly, based on our finding, we provide specific recommendations to mitigate these risks, such as redesigning workstation or implementing job rotation. Finally, we aim to establish standardized procedure for handling and transferring wafer. These procedures are designed to not only enhance safety but also improve overall efficiency in the workplace. By achieving this objective, we ensure the Longi continues to prioritize worker well-being by maintaining its operational efficiency.
Next, we're going to talk about the safe work procedure for wafer transfer to cart. So first is preparing for the wafer transfer. So the worker check the wafer container's weight, size, and also the condition before handling it. They position the cart close to the storage area to minimize carrying activities. Next is to lifting wafer container from storage. So the workers stand with a feet shoulder width apart, bends at the knees, not the waist, and use legs muscle to lift the container while keeping the back straight. Next is to carrying the wafer containers. So the worker hold the container close to the body to keep a natural posture and walk carefully to the cart. Mechanical tools can help to reduce the strain. Next is to place the wafer container onto the cart. So the worker bends at the knees to lower the container onto the cart. If reaching higher shelf, they use a step stool or ladder to avoid overhead lifting. Next is repeating the lifting process. So workers rotate tasks to avoid strain. For heavy containers, they lift with a partner or use lifting tools like pallet jacks or vacuum lifters. Next is to move the cart. So the worker push the cart with both hands using legs muscle and keeping a neutral posture. Containers are secured to prevent shifting. So transferring wafer container from cart to the warehouse storage. So the worker use proper lifting technique to unload containers from the cart, ensuring safe placement by using step stool for higher shelf. So here is some photos for the example on the wafer transfer to cart. So for the methodology, we use the ruler method used to assess the ergonomic risk assessment. So this ruler focus on the posture of the upper limbs, neck, trunk, and legs, as well as force exerted and repetitive movement. The score obtained from the ruler method divided into action levels, which indicate the urgency of the corrective measure. For the checklist, the assessment also incorporated Appendix 6 checklist from the Guideline on Ergonomic Risk Assessment at Workplace 2017. The checklist helped to systematically evaluate various aspects of ergonomics, including work posture, manual handling, repetitive motion, and workstation design. For the data collection, we used to observe the worker while performing their tasks, conducting interviews, and reviewing workplace design and task processes. Collected data, photograph and video taken during the assessment to capture different work posture and workstations. So the assessment tools that we're going to use is for the assessment is ruler score sheet used to analyze posture and assign a risk score. Next is ergonomic risk checklist from Appendix 6 of the guideline, which include key areas such as first one is the work posture and movement, second one is forceful exertion, third one is repetitive movement, and fourth is the manual handling. So I will pass this slide to the next one.
Alright, for data collection, it is based on the Appendix 6. For ergonomic risk assessment checklist, we have work posture, repetitive movements, forceful exertion, workstation design, and manual handling. Starts with work posture, the data regarding how workers were positioned while performing tasks. For example, whether they were bending their head, back, reaching overhead, or twisting their bodies. This was collected through direct observation and video analysis. For repetitive movements, data was gathered on how frequently the same motion was repeated during tasks. This was measured by counting the numbers of repetitions within a specific time periods. For forceful exertion, information was collected on tasks requiring workers to use significant force, example lifting heavy object or applying pressures. This was identified through task observation and interviewing employees about the effort required. For workstation design, data was collected on adjustable and ergonomic design of the workstation. This was done through a visual inspection of the workspace. For manual handling, data was gathered on how workers manually handle objects, whether they lifted items safely or carried heavy loads incorrectly. Observations were made during manual handling activities, such as moving materials or assembling parts. Alright, let's continue with the data collection. Based on the previous category, we have work posture. The item is the worker adopting awkward posture, for example, bent wrist, twisted back. Based on the finding is yes, the risk level is high, and the comment and action is adjust workstation to allow natural posture. For category repetitive movement, are the same motion repeated frequently? The finding is yes, and based on this, the risk level is medium, and the comment and action is implement job rotation and micro breaks. For forceful exertion, are tasks requiring significant force, for example, pushing, pulling, and lifting heavy loads? The finding is yes. Based on this, the risk level is high. So the comments and action is provide mechanical aids and ergonomically designed tools. For workstation design, are the workstation adjustable to the worker's size and posture needs? The finding is no, and the risk level is high, and based on this, the comments is introduce high adjustable workstation. For manual handling, the item is, are the manual handling tasks performed in safe posture? Based on the finding is no, and some observed with poor lifting posture. And for the risk level, it is medium, and the comment and action is provide training on safe manual handling techniques. And for environmental factors, is the lighting, temperature, or noise affecting workers' posture or action negatively? And the finding is no. Based on this, the risk level is low, so the comment is maintain current environmental conditions. Based on the ruler scoring table, the ruler rapid upper limb assessment scoring is used to evaluate the postures of the upper limbs, trunk, and legs. And based on the task, assembly line task, the body region are upper arms and trunk. The score given here is 6, and the risk level is high, and the action required is immediate corrective measures. For packaging tasks, the body region are neck and upper limbs. The score is 4. For the risk level is medium, and action required is further investigation and changes. For quality control tasks, the body region includes shoulders and wrists. The score is 5. The risk level is high, so the action required is immediate corrective measures. For lifting heavy object, the body region includes trunk and lower limbs. The score given is 3, and the risk level is low, so the action required is monitor and reassess as needed. For ruler posture assessment summary, based on this, for each body part, neck, trunk, upper arms, and wrists, data was collected on its specific posture during task performance. This was done using observational techniques with deviations from the natural posture. For example, bent neck, forward lean were recorded. So videos were used to analyze and validate posture. And the result, for body part of neck, the posture observed slightly flexed forward, and the ruler score is 2. And the comment is needs for improvement and adjust monitor heights. For trunk, the posture observed is slightly forward bend, and the ruler score is 3. And the comment is requires support, adjust chair backrest. For upper arm, the posture observed is raised above shoulder level. The ruler score is 3, and the comment is change task design to avoid shoulder elevation. And for wrist, bend sideways during assembly. The ruler score is 2, so the comment is provide wrist support or modify hand position. For ergonomic risk checklist for specific tasks, the ergonomic risk factors, the first one is awkward posture. Based on the observation, it is yes, and the comment observed during repetitive arm movement. And for repetitive motion is yes, and it is observed during continuous use of tools for packaging. For high force exertion is also yes, it is during heavy lifting involved in moving parts to assembly. For poor workstation design, it is on a non-adjustable height of work surfaces. For lack of rest breaks, the observation is yes, and it is based on workers do not take enough rest during shifts.
Assalamualaikum and hello everyone. My name is Nur Shamsina and I am going to continue with our group presentation for the assessment finding. Our assessment reveals several key points regarding the current state of the workplace. Firstly, with the overall organization of the workplace is satisfactory, we identified certain tasks that force workers into awkward posture and involve repetitive motion. This poses potential ergonomic issues that could lead to discomfort or even long-term musculoskeletal disorder. Secondly, we observed that some workstations lack sufficient adjustability. This results in workers having to maintain poor posture, especially when carrying out tasks at varying heights. Without proper adjustment option, employees are at risk of strain, particularly in the neck, back, and shoulders. Lastly, the placement of tools and equipment within the workplace is suboptimal. Employee often has to exert additional force to reach or operate them, increasing their exposure to the risk of work-related musculoskeletal disorder. Addressing this issue through improved ergonomics and workstation design will significantly reduce the physical strain on workers and enhance overall safety and productivity. The assessment conducted focused on two key areas, which is RULA, Rapid Upper Limb Assessment result, and the Ergonomic Checklist result. The RULA assessment identified several high-risk tasks. The assembly line task, which primarily impacts the upper arm and trunk, received a high-risk score of 6. Immediate corrective measures are required to address this issue. Similarly, the quality control task affecting the shoulder and wrist also received a high-risk score of 5, necessitating immediate intervention. The packaging task, which involved the neck and upper limb, was classified as medium risk with a score of 4. These tasks require further investigation and potential changes to minimize ergonomic risk. Lastly, the task involving the lifting of heavy objects, which affect the trunk and the lower limb, was considered low risk with the score of 3, but regular monitoring is advised to prevent further complication. As for the second one, which is ergonomic checklist result, the ergonomic checklist result highlighted several areas of concern. Work posture was found to be the significant issue, with employees often adopting awkward posture, particularly during assembly tasks. This was classified under high risk, and posture correction as well as workstation adjustment are recommended. Repetitive motion, especially in packing and assembling tasks, were observed to be at medium risk. Introducing rest break and implementing job rotation strategies would help mitigate this issue. Manual handling of material was generally considered low risk, but there are instances where lifting required excessive force. In such cases, providing proper lifting technique training is essential. Workstation design also posed a high risk due to lack of adjustability, leading to poor posture. Implementing adjustable table would significantly improve ergonomic. Lastly, some tasks required excessive force, particularly in the assembly process, which was classified at high risk. Providing ergonomic tool to reduce force exertion will be crucial in addressing this issue. So moving on to the recommendation part, to address this issue, implementing adjustable workstation is highly recommended. Adjustable station can accommodate workers with different height and tasks, reducing awkward posture and improving comfort. Providing ergonomic tools such as powered tools or those with ergonomic grips will help reduce force exertion during high-risk tasks like assembly work.
Job rotation and scheduled rest break are essential to reduce the strain from repetitive motion in packaging and assembly tasks. Studies shows that rest break and task variation lower fatigue and the risk of repetitive strain injuries. Regular training on proper lifting technique and ergonomic practices should also be conducted to promote safety and awareness in the workplace. Lastly, periodic ergonomic assessment using tools like ruler and checklist should be performed to track progress and identify new risks. Continuous evaluation will help maintain a proactive approach to workplace health and ensure a safer environment for the employee. The finding of this assessment highlight the need for immediate and sustained effort to address economic risk in wafer transfer and lifting tasks at Longi. High-risk tasks such as assembly line work and quality control require urgent intervention, including workstation adjustment and provision of ergonomic tools. Medium-risk tasks like packaging demand further investigation and the adoption of job rotation and respect to mitigate repetitive motion risk. Although low-risk tasks like lifting present fewer immediate concern, continuous monitoring is essential to uphold safety standards. By implementing this recommendation, Longi can reduce incident of WMSDs, improve worker well-being, and boost overall efficiency. A commitment to ergonomic safety not only enhance employee health but also underscore Longi dedication to maintain a safe and productive workplace. So that's all from our group. Thank you.